So, good day. So, good day. I believe what we'll be attempting today is the intermediate weekly card question. So, as you can see, this is the orthographic projection of the model we are asked to design, and we are asked to find minimum factor of safety. We should design this part, that's this part, with the appropriate dimension as mentioned here. Apply the material 1060 alloy. Apply a fixed geometric fixture to the six inner surface. Look at it. This is the surface that has six faces. Simulate it gripping a stationary bolt. Then apply a 200 Newton nominal force perpendicular to the narrow side face of the handle to create a realistic twisting moment. So this is what they are asking us to do. At the end of the day, we have to find the minimum factor of safety of this part. So what we are going to do firstly is to design this part. So let's go to our SolidWorks. So I create my new part. So this is actually a part. So I may not be going into the technical details to explain this, how to calculate the stress, and then tell you what factor of safety is. I assume that you're all engineering students and you know what factor of safety is. But should in case you don't know, you can as well ask your AI system to explain for you. But then let's go ahead to design this. So the first thing, just like the way this is, we can assume these are front. So let's design it the way it is here. So let me bring this down a bit. So I click on my side front plane. So, and to create something like this, you can choose whichever part to be your center. For me, I choose to go with this to be my center. So what I can do is to create a straight lines to serve as my horizontal, as my origin. Then I have to create these other parts that you can see here. So to create all these parts, there are a few things I needed to do, which is firstly, I needed to create this and this, and then the cycles that you see in here. So to create this cycle, I go and I select my part, circle, I create this, and I come here to create this. You may be asking, why didn't I select the center? I have my reasons for doing that. So this cycle, from the dimension here, you can see that this cycle is radius 10.16. Likewise, this 10.16. So take that. So what you are going to do is to, okay, dimension this radius. If radius is 10.16, multiply it by 2 to get your diameter. So this is your diameter. Make sure your unit is mmgs. Very important. So we have gotten this. We can just equal this to this instead of having to dimension it again. Make sure this center is horizontal to this line. They are coincide. So we've created this. Now the first thing we need to do now is to say, okay, what's our distance from the center to the center? We don't know, but we know the distance from this edge to this edge, which is something. So not to waste much of our time, we can create this that is inside 12.70. So to create this that is inside, we click on this and we create, this is just a, so from here to here is 12.70. So get that. Make sure this is horizontal. So you can see immediately when I made it horizontal, it's totally aligned. And this line. So what I needed to do now is to create something like this by this side. So now I also come here. Now the center, sorry, click this. I want to make sure that this coincide at this point. You may not understand what I'm trying to do, but you do that, you get to understand that later. So I've been able to create this. I bring this downward, inward a bit. So if you are looking now, you can see what I'm trying to do is gradually coming to life. So what I will do is create a line here. You can as well use any approach, but mustn't be the same approach I'm using, depending on what you're familiar with. So I can as well see that the distance from here to here is the same as this 12.70. So from here to here, 12.70 as well. So this, I move this. The idea is to make sure that this is, so I can move this inside a bit. Idea is to make sure that there is a line. Okay, I've already created a line. So now that I've done this, I don't need all these parts. So I can remove them. Just erase them. You can erase them, or you can, okay, let's just go back. You can as well just say trim. You trim this, you trim this, trim this. You don't need this. So you need this part, so you can trim this, trim this, trim this, trim this, trim this. You can trim it. I like to use my trim to closest, so because it's a bit easier to do that. I don't need this edge, and I don't need this. So I please try to dimension this back, because when you trim it, the dimension is out. So make sure you dimension it back. So now the distance from the middle to here, it's given to you. You can see from here to here is 106.12. 106.12. So you come here to here. So 106.12. Very important. I know you may get something weird like this and get discouraged, but don't be discouraged. What you just need to do is to make sure this and this, they are horizontal firstly. So you make sure this is horizontal. Why are we getting this line? You have to try to understand why we are getting that line, because this point and this point are touching. So the first thing, you can say you want to delete the line, delete that point to get this, but I will not advise you to do that. So just go back. I think it's my fault. It's my fault at times. Let me just go back and make this and this as well horizontal. So when I'm creating this, I make sure that they are parallel. So make sure you make them symmetric, I mean. So once they are symmetric, I can now go ahead to say I want to dimension from here to here. 106.12. Okay, let me be sure. Please forgive me. Let me check this. Okay. Okay. From here to here is 4.61. So let's do that first. 4.61. Come on. Oh, where's my solid block? So let's just remove this. So from here to here, 4.61. So let's get that out of the way first. So go back here again, check from here. Okay, from here to here is 6.35. You see, there's a mistake from me. From here to here is the 4.61. So a mistake from my own end. Then, you see, another mistake. Sorry. Uh, another mistake. So you need to check these things properly. A bit tired, sha. So from here to here, you can look at it 10.16. That's diameter. From here to here. Oh. From here to here. 10.16. So that's that for that cutting. Then from here to here is 6.35. From here to here. So you'll be getting this eventually. There are reasons why this is giving you this error. Now let's not dwell on that. Firstly, let me see. What I'll try to do is to delete this. This is partly the reason why. Okay, I'm on dimension. So I click this, remove this. So this is okay. Still showing that a lot of troubleshooting to do. This as well. Let me please also make sure to drop your tool. So delete this. Let me just delete this. So coincide this with this as well. Just because of the way we created it. There are better ways you can do it. But this is just the first thing that came to mind when I was doing it. So this is what's going on. Come on, what's going on? Okay, so that's another reason. So this is 6.35. 6.35. So pardon me, can be too much at times. So from here to here is 4.61. Look at it. The dimension is from here to here. So we don't need this for now. So we are good with this, and we need this 12.70. 12.70. We've gotten this. Now you may be wondering, why is this not? It's because it doesn't know that this should be aligned with this. So align it horizontal and vertical. So immediately it is this. So make sure this and this are equal. So you see, properly adjusted this. So it doesn't know the length from here to here. Like I told you, the length is what? 106.12. So you come back here and say from here to the middle here, 106.12. So you can see that it has properly arranged this. Now you may be wondering, why is this still not fully defined? Because it doesn't know the length of this side. It is a problem. So but we'll solve that later on when we dimension this side. We'll solve that. So the next thing we need to do is to get the distance from here. From the middle to this point is 5.0 likewise. So these are the middle. So what we just need to do is to offset this. So offset this bidirectional, and I say 5.08. So this is 5.08. So we've gotten this. You can say good. Now what you don't need is this part. So you trim it out. You also don't need this. To be sincere, you don't need this. Now you don't need this. Likewise, you don't need this. You don't need this. You don't need this. Likewise, you don't need this. You don't need this. You don't need this. So you have successfully gotten this. Now what you need to do is now to look at this dimension they gave you from here to here to be 82.55. So from here to here, 82.55. So from dimensioning this, you see you don't even need to dimension this. I purposely made some of this dimension over defined to stress some dimension out for you guys, because I know some people will be finding it difficult. A whole lot of you that may be doing this are beginners, so you may be finding this difficult to do. That's why I had to make some of the dimensions over defined. So now that you've done this, sorry for taking your time. Now that you've done this, you can go ahead to create the 3D of this. This is extruded. Um, from this, you can see this is extruded 7.62. 7.62. So you extrude this. I always like to do is mid plane. So mid plane 7.62. So you can see we've gotten this. We've been able to create this. So we've been able to create this. Now the kind of FEA analysis part that we need to do. Now to do the FEA analysis part, let's save this model firstly. Let me just, I have a folder where I save this. I like to call this the intermediate. 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 So we'll save this part. Now, first thing I would like you to do is to apply material aluminium 1060 alloy. That's what we've applied. We've applied material. So the next thing you do is to do your analysis. So firstly, they said from the question of the analysis, you have to make here. So fixed geometry fixture to the six, apply a fixed geometry fixture to the six inner faces of the hexagonal box end to end. Simulate it gripping a stationary bolt. So these are the six faces. 1, 2, 3, 4, 5, 6. Okay, did I count? So this is 3 up, 3 down. So that's 6. 6, that's hexagon. So hexagon 6, heptagon 7. So we will now go and then go to our, okay, you may not be seeing your simulation here. So you may have to include your simulation in your tree. So but I already have, you go to add-ons, then you click simulation, and then you have to select, it may delay a bit depending on your system graphics. So it's delaying a bit, system will have to load a bit, so give it a few seconds. So it's a bit better now. So you can now go to, you see your simulation will appear here. You can now go to new study. You want to create a new study, permit me to bring this down. Now just go ahead with your static study. Don't change anything here because much of what you are trying to do is a static study. So you apply. So your fixture now. First thing is to apply your fixture. So you can double click on it and select, click on it and select the kind of fixture you want, a fixed geometry. So a fixed geometry, what are the faces that you need to select? 1, 2, 3, 4, 5, 6. So these are your 6 faces, Ctrl 7 2. So you've selected this, just click good. Selected your 6 faces. So the next thing you are asked to do is to simulate its gripping a stationary bolt, then apply a 200 Newton normal force perpendicular to the narrow side. So you have to apply a 200 Newton force. So come here, force, then you apply your force. 200 Newton SI. So it will be in Newton. So there's no need, don't change anything. Purposely do it here so that you don't have to change anything. So you apply the force on this face and then you click good. You've applied your force. Now, what next do you do? You've applied the basic things that you need for your simulation. You run your mesh. So you can come here, click to run your mesh, apply mesh. Most times, a mesh and run. Sometimes you can come here and click here, run your mesh study. So your mesh study will start to generate. It will generate your mesh study, and then this is your mesh study. This is what you have. Isn't it beautiful? Isn't it wonderful? So there you can see that the von Mises stress is here, the yield strength is here. Because you applied the material before, that's why you are able to do this. You apply material, you will not be able to do it. So now what they ask you to find the factor of safety. So forget about this. So what you need to do is to click here and say define factor of safety plot. So when you define your fact, don't click anything, just automatically you define it. So when you do this, what do you see? Your factor of safety is 0.25. This is factor of safety distribution, minimum factor of safety 0.25. Criterion, automatic criterion. So you've gotten your factor of safety. So you have successfully answered your intermediate question.